All right, welcome back. We're going to look more at statistics and we're going to do some analysis on the small data set here. This is a made up data set, not a reference to anything in particular. I just kind of engineered these numbers to work out the way that I want them to for our particular usage here. So there's nothing special about this data set, but we will look at some more other data sets that are a little bit more interesting here in a little bit in other videos. So what I'm doing here is I'm going to make a box and whisker plot, and we're just going to do this by hand. Now, one of the things I did for the sake of time is I went ahead and put these in order, which is the first thing you need to do when you do a box and whisker plot. So you just simply have these in order, and then we want to find the median. So going in from the outsides, we want to count in until we get to the middle, right? So we go 27 and 8. 19 and 13, or 13 and 19 rather, yes, and 15 and 18, which means right here is our median. That's the middle number. Now, once again, what this means is that 50% of the data lies below and 50% of the data lies above that. So when we look at drawing our box and whisker plot, and we're going to do this vertically, we're talking about the lowest value being down, let's just say right here, 17, right? So right here is our median. So half of the data lies below that and half the data lies above that, so above and below. So we'd count this out as best we could. So right about, say, here would be 9, or 8-ish, I guess. So let's go ahead and call that 8. And then we want to kind of say that same space up this direction right here would be 25-ish, 8 up, 8 down. And 25 more or less takes care of the span of all of our data points here. All right, so right in between that. All right, so we went, I guess that's about 9 up and about, I guess we should have gone up 9. So maybe about 26 here, I guess is what we should have done. All right, and that is mostly our values. So right in between here, that'd be our low spot here, just marking our values here, and our high spot of 27, which would be just above that, so right here. And any time we're not directly on that line, it's a good idea just to go ahead and say it. So here's our max at 27. Here's our min at 8. And here was our median at 17. Now, what we need to then do is look on either side of that. So we're looking on either side of that, and we have this data set on either side. We have halfway in between there would be 13. So right here is Q1. Same thing on the other side, which means 19. So half of that would be halfway in between 18 and 27 would be the outside. And if we had other values, we just counting in, this would be Q3. All right, so that's our first quadrile, and our third quadrile. All right, so we just mark those as best we can. I don't have grid paper to do this with, so that would have been better. And we go to 13, which would have been, if this is a span of 9, halfway would be 4.5, which would be about 12.5, so right, just more than halfway. So right there's Q1, which is 13. Going up the other direction is 19, which is just 2 above, so it's going to be a little bit tighter of a span there. So right about there. A little bit too far there. There is Q3, which is 19. So what we do is we box around these values here and just kind of shade them in a little bit, and then we draw lines out this way to create the box and whisker plot. Now what this tells us is that 50% of the data is contained inside of that box. Half of all the information we would have would be contained inside of that box right there. And then we'd have 25% here and 25% here. In fact, we have 25% in each section of this, which is why we call these quartiles, is because we have a quarter of the data. So half the data lies in this section, a quarter between here, a quarter here, a quarter there, and a quarter there. So we could say 75% of the data lies above 13. 75% of the data lies below 19, which is kind of interesting to look at. So if we look below 19, 75% of the data is inclusively between 19 to 8. Kind of wrote that backwards, but that's okay, right? So that's a span, if you think about this for a second, that's a span of 7. No, that's not a span of 7, that's a span of 9. It's a span of 11. Oh my goodness gracious. Anyway, so it's a span of 11, right? If we do the other direction, we talk about above that, 75% of our data, and this was from Q1 to Q3, right? If we go from, no, this was from min to Q3. If we go from Q1 to max, all right, that is going from 13 to 27, which in that case is actually a span of 14. So it's not that it's necessarily evening out like the middle of the data. Like when we talk about mean, we're actually finding the middle, not necessarily the middle number, but the middle value that we're not necessarily putting it in half above and half below like we are with this. The median is half above and half below. Here is 75% of the numbers. And when we talk about mean and standard deviation, it's a completely different discussion. We're not saying half of this or half of that. We're talking in terms of, we're setting up a number and saying how much the data is actually inside of this realm, which is one of the discussions we have when we start talking about, well, which is the better descriptor? Okay, so when we say maximums and minimums, we're referring to the largest values we have in our set. When we say the upper 75%, we're talking about from quartile 1 to the max, which in this case has a span or a range of 14. And we say the lower 75%, we'd be talking about from the min to quartile 3, which had a span of 11. So it's the number of data points that's in here, not how far the data points are spread apart. With standard deviation and mean, we're actually kind of standardizing the distance, and we're seeing how much of the data is in between there. Here we're saying we have 75% of the data. What's that span, or what's that space between them? So it's looking at the same information in opposite directions to see which one is a better descriptor for what we're dealing with. There's a short, quick version of box and whisker plots and how they can be useful to us, and there's more information about this to come in later videos. Take care.